Hi, I'm Craig Rowland, founder of Sandfly Security. In today's video, we're going to go over a feature called SSH Hunter. SSH Hunter is Sandfly's capability to track, identify, and help you find keys that are being used for SSH access across your enterprise, maybe even for rogue reasons. This is a powerful feature in our product, and being agentless in nature, we can get onto any system, whether it's a cloud-based server, on-prem server, or even embedded devices, and help you find SSH keys, how they're being used, who's using them, and whether or not they might have moved into areas of your network where you don't want them to go, such as, for instance, persistence mechanisms. So let's jump over to the user interface and we'll get going, show you how this powerful feature works out and how easy and fast it is for you to deploy it today. Okay, I've logged into the user interface and we're going to talk a little bit about SSH Hunter before we get into the nuts and bolts of how it works. Basically on Linux, SSH keys are a major way for people to access these systems to do admin tasks, automatic deployments, backups, basically anything related to the administration of Linux enterprises. But SSH keys have a huge problem in that they're very easy to get stolen. They're frequently mismanaged with lots of private keys lying all over the place. And as people come and go and need access to boxes, a lot of times we find keys get left behind, what we call an orphan key. They never get removed. Nobody knows why a key is there, who's using it, or why it's being put in. And even worse, keys could be inserted by malicious actors in order to maintain persistence and backdoor access onto a host. And because so many keys are usually lying about, administration and security teams frequently don't have any idea of knowing whether or not the keys actually belong there. So SSH Hunter is our ability to agentlessly get onto a system, identify users and what SSH keys that they're using, and then map those keys back so you can quickly see where those keys have access to across your enterprise. Now, when you log into the user interface here, you'll notice here we have 3 alerts, which we'll get into in a moment here. But some basic information on the dashboard down here, we have something called SSH security zone violations. And we also have a new area here for new SSH keys. And this will show you keys that have shown up in the past 72 hours by default. Now, we don't have anything here yet for these demo systems, but we're going to go over to the SSH Hunter. I'm going to give you a breakdown of how this is going to work. So let's hop over to that section right now and have a go. To access SSH Hunter, we simply go over here to the SSH Hunter on our side tab, and we're going to get several different areas about things going on here. First of all, our SSH summary. This is going to show us things like number of security zones we have, number of keys we have access, number of SSH users we have currently on our network, and the number of hosted SSH keys. Now, obviously, for demonstration purposes, we have a limited number of systems. So we have 25 hosts with 7 users and 13 keys total. But we have customers that use us to track and monitor SSH keys across thousands and tens of thousands of hosts and thousands of SSH keys. So we can scale up to handle a very large number of SSH keys. And in a lot of Linux enterprises, this actually becomes necessary because SSH keys have really grown out of control for a lot of you. But we're going to help you get a better understanding of how those keys are being used. So that's what the summary does. The next area here is what we call SSH security zones, which I'll talk about here in a moment. But basically, this SSH security zone concept means we can mark certain areas of the network with tags and say, for instance, these are our production systems and these are our development systems, as I have here in the demo. And then I can identify what keys are allowed in those areas, what we call the zones. If a new key were to show up, then the zone will go red and tell you that a new key has been introduced into these areas to allow you to go investigate it. The next area is what we call key investigation. This is going to list out all the keys and what hosts that they have. You can sort here by hosts. So for instance, here, this key called Dicing Hurricane Candle has 5 users with 23 active hosts. If I click on one of these keys, a couple things you're going to notice here. First of all, this is just a human readable text of what the cryptographic key actually looks like. Because humans are really bad at looking at random blobs of cryptographic material, we actually give it a unique name so you can identify it. Second of all, we'll give you things like the tags, the security zones it's in, the first and last time we saw the key. So you can see here, for instance, we first saw this key in 2022. So this is an old key. And the last time we saw it was just right now before this demonstration happened. But the thing about the keys to understand is once we see a key, we will always track that key. So if you remove a key from your enterprise, like let's say you say, this is an old backup key, we're not using it anymore, and you delete it, we will still keep it available in our database because we have found if that key returns, we can suddenly start tracking it again. So why would a key return like that? Well, we have seen it happen for a variety of reasons. One of which is simply someone restores an old backup, and now all of a sudden a key that you thought was killed shows back up, what we call coming back from the grave, basically to allow people to access it again. So by always tracking keys, it allows us to show you over time kind of what they're doing. You can see information about the SSH key type. This is an SSH type SSH RSA. We only pull public key data. We never pull over a private key. So you can get the full public key data here if you need to. We can also get the hashes of those keys, and this could be used to help track keys by hash instead of the full public key value in our searches. So we could actually track these keys, and you could put in by simply putting in the hash into your seam. You could basically show where that key is across all your systems. Down here, we show what we call a key use timeline. This will be the first time we saw that key on this current set of hosts. So these hosts were set up fairly recently. We first saw it back here in 2025. Now, these are cloud-based demo systems that go up and down all the time. But what you would see over time is if this key was moving across your network, here you saw it just showed up all of a sudden, but you would see kind of like a stair-step movement across the screen here as a key starts to be seen on more hosts, it'll grow out. Now up here, we call this the visualizer. And if I go over here to this tab, I can make it full screen. And when I click on these, I could see immediately what the host that key is on. So for instance, this host down here, this Rocky Linux host, has 2 users who are sharing that key. So I can see here that key is being shared by the root and the operator users. Down here, I can see that there's 3 users sharing that key, sfscan pw, sscan, and root on this system. But it gives you a general overview of hosts that have that key, or you could view it by users. So I could say, show me all the users who are using this key, and it's going to show me here, I got 5 users that are all sharing the same key over here. The next thing I could do, I could click on the host tab. The host tab is going to show me all the hosts that are currently running with this key active on some user. It doesn't have to be the same user, but what we're showing you are these are all the hosts that have this key active, which means someone can log in to that host with this key. The next thing here, this is going to show you again all the users that are showing that key. So now I can immediately see that there are 5 users who are sharing this key. Now, generally sharing SSH keys is a bad idea, but you can also see a lot of interesting things here. So for instance, I see some default users like root and operator here that are using this key, which means someone is using this key to log in as root somewhere in one of my hosts. And finally, the zones here, which we'll talk about in a moment, this shows you all the systems that are allowing this key to log into that security zone. We'll talk about this in a moment here. But the basic thing to understand is that we have all the information about that key at our fingertips. The next thing we have down here is what we call a user investigation. And this is basically a different pivot view into that user. So for instance, on this host here, I click on root and I can see all my root users and what hosts they have access to. So again, down here, I could see that they have all these, this root user can access all these different hosts. And you can see here too with this key, I can see here the number of keys that root user currently has linked to them. So right now I can see a large number of keys that are linked to that root user. And again, the key timeline shows me over time how keys have been added and removed from that root user. You can see them here. Now there's some interesting things we'll flag about the keys that you probably noticed. First of all, duplicate key. So what does that mean here? Well, if I go over here to my host and key entry, I can see here has duplicates. If I expand this out, what it's going to show me is it actually show me the authorized keys file for that user on this host. And for this particular key, outnumber showcase reflected, down here you can see that there's a lot of duplicate entries here. It's and I could sort here by, I could sort here by the OS, and down here I could sort by the entry number. So the entry number is going to show me, entry number 1 is this key, entry number 2 is this, but then entry number 3, 4, 5, 6, 7, I see all these duplicate keys happening here. Now, what that means, this means 2 things, and this is a common thing, these duplicate keys. Let me tell you, first of all, why it's a problem. It's a problem because if you're looking at an authorized key file by hand, all you see as a human is, again, a big, huge list of random cryptographic key material. They frequently don't have any other identifying information. Yeah, you might get lucky and get a comment in there, but that comment is frequently automatically generated. It may not tell you anything at all about that key. So if you, let's say, have a list of authorized keys and you have an entry at user number for a user at entry number 2 and another entry of the identical key at entry number 10. And let's say that user, you want to get rid of them. Let's say it's an employee who left or it's a service you no longer need, whatever the reason is. You go and you look at that file. You say, entry number 10 is our key. I'm going to delete it. You save the file and you think all is good. But that's not true because SSH will authorize based on any key in that file. So if you have a duplicate key and you delete it at line number 10, but it was still present at line number 2, that user can still log in with that key. Now, this is a very significant problem. We've seen it a bunch. And the reason it'll happen on a typical Linux system is basically two things. Well, let's say three things. A human error, someone just inserts a key another time because they don't think it's there already, because again, humans are bad at reading random text. Number two is it could be an automatic key management system that has added the key at one time and then for whatever reason didn't clean up the key. Now, these key management systems are very good at adding credentials, but sometimes they're very conservative about removing them, and the keys can be left behind. We have seen this happen multiple times where you think you're rotating a key and no, it's not being rotated. In fact, it was inserted in that file multiple times by the key management system due to some bug in the software. The third way we see it is through a persistence mechanism from malware that's very unsophisticated. Usually a malware will try to insert a backdoor key. It doesn't check if its key already is present, so it just keeps inserting the key every time it reinfects that host over and over and over again. So these are the three things. So these are some of the key anomalies that we could find in terms of a user, and that's another aspect of our product that's very important. The last thing here is what we call host investigation. Host investigation, again, is another pivot view that's going to show you the number of users on a host. So I'll go onto this host here called Drifted because this is going to be part of our demonstration. If I click on this, it's going to show me on the Drifted host, there are 4 keys being used, and there are 4 users on my host that all have some type of SSH access to the box. Now we have different users here: root, SSScan, SSScanPW, and Johnny, and each one of these users has different key potential access to that system. So those are the pivot views of how SSH Hunter can help you organize keys that are getting access to your systems. Now, the last thing we're going to do here is I want to talk a little bit about something called the tag workbench. So let me go ahead and hop over to that user interface portion and we'll get started. Okay, the tag workbench. This is an area that we find customers need to use because a lot of times they have way too many keys on their network. You'll be surprised when you run our product how many keys we're going to dig out that are just basically hanging out all over the place. It's a real mess for a lot of organizations. So we wanted to give customers a way to kind of start getting a handle on the situation. You might have thousands of keys and you're like, well, how do I hide nor hair of this? I have no idea. The tag workbench allows us to do it. First of all, we could show you, and I'm not going to be able to go through everything. I'm just going to give you a general overview of how this works. We can have keys with no tags, but I can also view, for instance, show me all the keys tagged on my DigitalOcean hosts. So these are all the hosts here that have tagged with DigitalOcean, and these are all the keys active on this host. So I can see immediately whether or not a key is somewhere where I want it to be, and I can also see it associated with certain users as well if I go back to the user browser. But this gives me the ability at this point, I could tag this key, for instance. I could say I could tag multiple keys, and I could say, right, these are all my keys. I'm going to tag them now, and I could say, you know, these are DO keys. These are all DigitalOcean keys. So at this point, these keys are all tagged with DigitalOcean. The other thing it allows us to do here is also show us all the keys that have been tagged as well. And this is useful if, for instance, let's say I have keys that are my production network. I go on my production keys. I could see, okay, yep, there are 3 keys here that are flagged as production, and I can always see all the hosts they have access to. And this way I can make sure that it's something that makes sense for our organization in terms of laying out where keys are and who has access to them. So that's kind of how the tag workbench works. Now you're going to use a tag workbench initially to tag the keys, because once you tag the keys appropriately, then we're going to use that to build up what we call our security zone, which is the last feature I want to talk about. So let's code over to the user interface and I'll show you that very, very cool feature right now. So I'm going to go here to the security zones tab on the menu. I see our 2 zones that I already showed you very briefly when we started the demo out. For test purposes, I'm going to delete this one called production, and we're going to set it up again so you can kind of see how fast the whole process is. So first of all, I'm going to hit add. And the first thing it's going to ask us is going to say basically what computer tags belong in this zone. And what we're going to say here is we're going to say, look, any system that's tagged as production, we want to include in this zone. The next thing we're going to do is what key tags belong in this zone. So again, we tagged our authorized keys that we want in our production systems with the tag of production. So I'm going to go ahead and pick production down here, and then we're going to hit next. At this point here, we're going to call the production zone, and then pretty much hit finish. Now, you'll notice here it went in and it's instantly red. The reason it's red is because we have basically a key that doesn't belong there. And why this is really cool is, again, if you have a large number of systems and only a small number of keys that should be on those systems, if you tag those keys that you know are supposed to be there, any key that does not belong and you don't know about, you're instantly going to get an alert that, hey, there's something in this box that you didn't authorize. So this can help you really find those orphan keys or perhaps malicious keys that were inserted on systems that went a long time not being noticed. But what we're going to do here now is we're going to click on production. And sure enough, we have our allowed keys down here. These are the 3 keys we allowed. In our zone here, we can see again, it's for production with key tag of production. I can see of my 5 systems that are in my production zone, 1 of them has already gone red. That means that this system has a key on it that was not flagged as part of the production zone. So we're going to want to go take a look at that. So when I go down here, I see all the information. I can see here all the users. I can see now here that there's users root, SSScan, SSScan PW. I have a user here called Johnny, and Johnny has given himself a key, and it's an entry number 1 in his authorized key file. So we'll look at that here in a moment. On the zone side, I can see again, it's just kind of repeat what this system belongs to in terms of what zones it belongs to. But the main thing here to understand is that we can also access this information as well through our Explorer here. And with the visualizer, I can see these are the 3 authorized key. This key does not belong here. This again belongs to that user Johnny, which we'll look into in a moment. But the main thing here is that through this process, I was able to set up zones to say, these are my production zones. These are the keys that are allowed to be on it. And the minute that a key shows up that doesn't belong there, we're going to get an alert about it. And what we've done here is we've actually flagged this user again, this user, Johnny. He seems to be a problem that we're going to want to look into. Now, we also have this show up in the results area of our product. So if I go up here to the results, you can see this Sandfly drifted. We have 3 results that showed up during our normal scans. First of all, this authorized key is shown up here for Johnny. And what we're saying here, there's authorized key zones violation that the user Johnny has an SSH key that, again, we have not been authorized to see in this zone. So we're going to give you all the information about that user here. I can also get the advanced result information down here for user Johnny. I can see Johnny has a shell. I can see Johnny has given himself a password. He's also has the authorized key. We can see the full data here about it. I can see here that he's also given us some interesting options that we're going to want to look into, that there might be something weird going on with that. And he's trying to port forward through our network, maybe again for lateral movement or pivoting attack. We can also run through an AI analysis if you have that set up for your system, so we can give you more information and AI analysis about what that key and that user might be up to. The other things we found on this system is, again, through drift detection. These green accounts we expected to see there, but drift detection has identified this new user Johnny has been set up. That wasn't part of the drift profile. This is explained in another video on drift detection. It's an awesome feature of Sandfly. You should really go check it out. But basically right now, drift detection has said this user doesn't belong here. This wasn't part of the profile that was authorized. The next thing we found here too was an authorized key file. Again, we saw authorized keys for these 3. That's normal, but Johnny here has given himself an authorized key file that was not part of the drift profile, so this is also an alert. Now, this is unrelated to SSH Hunter. This is related to our drift detection, but they work together to really give you a very powerful way to monitor systems, especially systems you don't want changing underneath you without you knowing about it. So basically, that's how the whole thing works here. The SSH Hunter is just an awesome feature. If you're running in Linux enterprise systems, I guarantee you almost certainly have SSH key problems. We've seen it a lot. They're horribly managed on a lot of different systems. They're very difficult to control. I highly recommend you do some type of auditing to make sure you know where those keys are, who's using those keys, whether or not they're going to places where they don't belong, and whether or not there are any other key anomalies or key problems that might be happening on those systems. So check out our other videos for more operational tutorials of Sandfly. Our agentless systems can help you watch anything from modern cloud infrastructure down to on-prem and even legacy embedded devices as well. So check it out. And I'm Craig Rowland, founder of Sandfly. Thanks again for watching the video. I hope you enjoyed it. Please leave us a comment or reach out with any questions. We're happy to demonstrate how SSH Hunter can help you protect your Linux fleet against attacks. Thanks again for watching, and goodbye.